Ready? Okay. There might be people coming in still, I guess they're still getting coffee and stuff, but we'll get started for the cameras. Welcome everyone, and I'm Dave. I guess maybe you know who I am by now. I'm here to talk about something that I guess has been dear to my heart for a couple of years now, and is closely related to the Cloud Foundry platform, actually, because that was my day job for a couple of years, ending it, I guess, a few months ago when I started working on Spring Boot. But I've still got my fingers in this pie and working quite hard on a new release for Spring OAuth, so I thought it'd be good to bring it here and show everybody a few new things and you know, get some feedback and everything. So here, in terms of the I/O platform, this is where we would sit. We're, you know, deep within the core, at least initially. Although, actually, when you think about it, if you're running an OAuth service, OAuth2 service, as a web application, then probably arguably you're at the top of the stack as well. So I'm at both ends. The Cloud Foundry piece that we run in production is at the top, and the Spring Security features that support it are at the bottom there. So this is what we're going to cover. How many people are already quite comfortable with OAuth 2? One or two. I thought that might be the case, right? So I'm going to do a quick overview of what it is and, you know, how you can maybe get your arms around it. It's not as simple as it might be, but it's a lot simpler than it could be. So I'll try and give you the basics so that we can start talking about what opinions you could have if you were implementing something with OAuth 2 or implementing an OAuth 2 service. Because basically the punchline is this: it's a nice spec, nice to read, you should read it. I'll show you the URL in a minute. Quite readable, quite nicely approachable. But it doesn't cover everything that you would ever want to do, with good reason, right? So it leaves a lot of, intentionally leaves a lot of things open to interpretation, and that's where we have an opportunity to step in and, you know, have opinions. And in this case, what I mean by opinions is modeling some data that represent the users in your system, the permissions that they have to access their resources, the way that those permissions are obtained by the various participants in the process. So there's a lot of data modeling that you can do. I'm just going to show you a few examples of choices that you could make and choices that we have made in the projects that I've worked on. I'll show you most of it from the point of view of Spring OAuth itself, because this is a Spring conference. But I'll also use, at least for demo purposes, I'll show you, I guess, as an exemplar of the kinds of choices that I'm saying that you can make. I'll use the Cloud Foundry UAA component, and I think I'll probably at least spin it up once just so you can see it working, because it's, you know, slightly different than the defaults that you get out of the box with Spring Security. Okay, so a quick intro to OAuth 2. It's got a number of different facets, but the way that it's most often used is this way, where you have three kind of machine participants: the authorization server, the resource server, and a client application. So the terminology is slightly confusing because often you think of client as being a person, as being the person who's using your resource, but actually that's reserved for a machine in this case. The client application, which is often a web application, acts on behalf of a user. That's the important thing, on behalf of, and the user is the person. But another key phrase, with the user's approval. And, you know, that could mean a number of different things. And it's one of the areas where the spec is intentionally vague, because getting the user's approval, that's literally what it says in the spec, right? The client application must obtain the user's approval in various scenarios. And it doesn't say how that should be done, and that's an opportunity, obviously, for us to step in and model something and implement it and make it a user experience or a not user experience, and make it happen automatically or make it happen with pretty colors or not pretty colors, right? There's lots of choices to be made. There are plenty of people using OAuth 2 these days, so common examples on the internet: Facebook, The Graph API is protected as an OAuth2 resource. Google, various Google APIs, in fact, I think all of them are protected with OAuth2. They have different authentication channels, so you can do it different ways, but OAuth2 is one of the ways that you can access those APIs. And Cloud Foundry itself, anybody been to any of the Cloud Foundry sessions at the conference? You saw me using it last night, right? Well, when I pushed an app to the Cloud Foundry platform last night, I did it on the command line with a Ruby gem. What that was doing was sending RESTful API calls up to the cloud controller, so-called in Cloud Foundry, sort of orchestration hub of the Cloud Foundry platform. And it was doing that on behalf of me, or the command line client was doing it on behalf of me. And so he had to carry information about me to the cloud controller, and there was an authentication header going up with all those HTTP calls. And that was the OAuth2 access token being used. Okay, so key features, in my opinion. It's definitely, in its class, one of the simplest ways to get started writing client applications which access secure resources. So if that's your use case, whether on behalf of a user or not, it's a relatively simple thing to get your head around as a setup compared to some of the things you could do. Key feature basically is that the client, like I just described in the case of the CF gem, is sending an access token in an HTTP header to a resource server. The spec, I guess, it does use examples which are all HTTP, but I don't think there's anything that would stop you from using different transports if you wanted to. It's just that the spec says, use the authorization header of the HTTP transport. I don't think there would be anything stopping you from using RabbitMQ messages or something to carry the same information. An access token is transported to a resource server. The resource server has to parse the access token in some way, has to extract information from it, and then make a decision about whether to deny or grant access to the resource that the client application is trying to get access to. And obviously, that's a security decision. Yeah? What about signing? Signing, I'll get to. Yeah, I mean, there are some use cases where you'd want to sign things and some where you wouldn't. Some people have opinions about that and some people don't. This is actually somewhere where I'm going to be on the fence for a change. Example, okay, so the resource server interprets this information. The access token comes in over the request. It would have to contain, at a minimum, I would say, it would have to contain the client ID, right? Because the resource server is going to need to know who is it who's trying to access this information. If it's also on behalf of a user, it probably wants to know something about the user as well, so it might have a user identifier so that the resource server can do permissions, access computations based on the user. It might have what I've called here the resource ID, so that would be in some parts of this domain, they call that the audience, so the audience for the token. When I mint a token as a client, I obtain a token from the authorization server. I have a kind of a target audience for that token. I want to send it to the cloud controller to deploy my application. So the token should contain that information. The client doesn't need to know anything about it, incidentally. As far as the client's concerned, it's opaque. But it should contain some kind of identifier for the audience so that when the resource server gets it, he can check that he is the right audience, right? And he should. This is kind of in words of the spec, right? He should reject any request that he is not the audience of, because who knows who's sending him it if he's the wrong person to be interpreting it. I mean, he's free to interpret any way he wants, frankly, but you should make sure you are the audience for this token, and you should make sure that it's coming from a trusted source, and that's where signing can come in, for instance, in some use cases. I'll talk about it later. Another thing that might be in the token would be the role assignments to the user who's trying to access you. So the token itself might be decodable into is this an admin user or a normal user? It might or might not. So all of this is completely open, basically, to interpretation. If you want your system to behave like this, you can, because all you're doing really is sending a string, as far as the spec's concerned, in a secure header between two participants in a machine conversation. So this is where I'm starting to talk about data modeling already, right? I'm starting to talk about maybe the token representing all of these things, maybe some of these things. I would say mandatory would be client ID and audience. User ID is optional because there might not be a user involved in this conversation at all. And role assignments could be to either to the user or to the client, right? So lots of choices, and I'll show you a few. Okay, so how would you obtain an access token? Well, one way you can do it, in fact the simplest, is as a client you can act on your own behalf. If there's no user in this scenario at all, then you can just say to an authorization server, this is what the sequence diagram is telling you. Sorry, the words are a little bit small. I don't suppose there's anything I can do about that. Maybe I can zoom in a bit. Actually, probably it won't work because I'll just change the font size and not the. Oh no, it does change a little bit. Is that easier to read? A bit. So the client is trying to get a token from the authorization server. It's a really simple conversation. The client says, "Please, can I have one?" And the authorization server says, "Okay, 200." Or he might say, "No, sorry, 403, you're not allowed to do that." Or it might say, 401, you didn't send me your credentials, right? So the client, this request should be secure and it should be authenticated. And so you can do that any way you want. The spec kind of suggests that the easiest way to do that would be basic auth, HTTP basic auth. Nothing wrong with that as far as I can see, but there's also nothing to stop you using any other form of authentication you want to for that. It's an HTTP request typically. So you can secure it any way you want. And once the client has a token, then he can start using it to access resources on his own behalf in that case. In the sort of, I guess, well, maybe they're equally common actually. I mean, at least in my experience, clients either act on behalf of themselves or on behalf of a user, and sometimes both. And that's actually also another opportunity for doing some modeling, which we'll talk about later if we have an opportunity. This is sort of maybe slightly more than 50% of the time. Certainly if you're a user, this is what you see all the time. If you're interacting with, an app that's deployed on Facebook, or something that wants to access your Google profile, right, on the internet, this is what's happening. You've got a client application which typically isn't, but could be part of the target platform. So if you're talking about Facebook, maybe the client application is something like one of those stupid spam adverts that I get on Facebook all the time now. Click on this and you will be rewarded by this, that, and the other. So the client is probably a third party, but doesn't have to be. If it's part of Facebook, then you would maybe see slightly different UI experience, but the client, fundamentally what the client wants to do is access this resource over here. That's maybe the Graph API in Facebook and maybe a Google profile. And when he does that, he's going to say, I'm client X, but I represent user Y, and user Y is standing behind a browser driving this process. And so the first thing the user does is go to the client and say, actually, I'd like to look at my friend's Google profile. Can you do that for me? And the client goes, oh, I know how to do that, but before I can do that for you, I need to get this token thing. And I get that from over here. You don't need to know this, but I'm going to redirect you there anyway, just so that you can approve what I'm about to do. So what you see when you do this on the internet is you see a redirect, and you see the Facebook authentication page come up. And if you've already authenticated, that will be skipped, and you'll see an approval page. And it will say, do you approve client X, app X? Do you approve their access to your profile? Will you allow it to write on your timeline? And then you click no. And then it has to react in some way. So it either gets a token or it doesn't. If it gets a token, then it can start using the resource. And so those are the 4 or 5, if you include the user as being a separate entity than the browser, which I guess it isn't really. 4 participants in the protocol of a typical web UI transaction. This one is ridiculously small. I'm not going to be able to blow it up, but I guess it visually tells you that the process there, the protocol is a little bit more complicated. It involves a number of redirects. And this is actually the case where the user is already authenticated, so it doesn't even involve that step. It's just user asks client for access to resource, client has to redirect to auth server has to obtain approval. And so I guess maybe I'll just zoom in on that quickly. Whoops. Since that's what we're mostly going to be in the business of today. That step there, so that's the user's been redirected to the auth server. The auth server says to the user through the browser, do you approve of the client doing this? And if the user says yes, then then he will be sent back a redirect to a place, to a location which is actually inside the client. So from the user's point of view, it's kind of a blink of an eye. You see, the client app comes back up again and starts doing stuff. But actually behind the scenes, if you followed it in the network trace, you would see several redirects going on. Okay, yeah, so I don't need to go into the gory details of that, just to, I guess, just to show that it's a slightly more complex profile than just asking for a token and getting one back. And it involves the auth server having a dialogue with the user, asking them for permission. So that summarizes it. The authorization server has to authenticate the user, right? You have to know who you are. So you have to be registered with Facebook or whatever it is that's issuing the token. The client starts that flow basically by sending the user's browser to the authorization server with some signal of what it wants to do next, right? So you basically the client sends a redirect to the browser, says, go to the authorization server and here's some data that will help the authorization server send me the redirect, send the user the redirect back to me. So you have a redirect URI that goes in the request there. The authorization server, if it obtains approval, will then issue a code. It's an opaque string, one-time token, if you like. Can be exchanged for an access token by the client. So that's a summary of the protocol, basically. And roughly speaking, the sequence of events here is the standard. It's a spec. It's what you implement. So it's our business to kind of have a look inside and see what choices are actually being made in there. So there's information being passed around, right? What information is available to whom, and what can they do with it? So first off, at least in the vanilla spec that we're mainly talking about today, I'll get into more complicated things like encryption and signing maybe towards the end. There are access tokens, which are, in the vanilla use case, they are bearer tokens. And the bearer token is a domain term, right? It means if you have the thing, then you can access the resource. If you're the bearer of the token, then you have full access to it. So it is, it's a trousers down event. If you've got one of these things, then there's no hiding. You can access all the resources you want. So that's an important consideration, right? So one thing you might do is make the bearer tokens opaque for the client, so the clients can't actually interpret the information in them in any way. For them, it's just a string that they get from Facebook and they send to Facebook, right? There's no informational content in there for a client. So if you're a client app registered with Facebook, they'll send you an access token, you can see it, and it's a gobbledygook string, and you can't actually decode it or anything yourself. That just prevents you from leaking any information about, the user or the resources that you're accessing. So that's good. Another thing is that it's going over HTTP in an authorization header. So it's a bit like a cookie, right? That's the same thing. It has the same kind of weight in terms of security and semantics. It's an opaque string in an HTTP header, which if you had access to it, you could impersonate the client on behalf of a user, right? You could impersonate the user. Same thing if you had a session cookie, right? If I've authenticated with a remote application and it sent me a cookie back, then chances are that's got state in it which can be used to impersonate the user. That's why you use HTTPS. And that's why the government's listening in all your conversations that you're having in HTTPS. But that's a different topic, obviously. So yeah, there are some caveats here, right? So you've got a bearer token, you can do anything, so you need to protect them. On the other hand, you can be careful and you can not reveal the contents of a token to a client unless it has some special permission or access. So the resource server treats any request that has an access token, a bearer token in it, is treated basically as if it came from the user. Okay, so what additional responsibilities, or what are the responsibilities of a client in this scenario? So and here's some opportunities for data modeling straight away, right? So first of all, the authorization server could, but probably won't, do anything with any client that it's never heard of, right? I mean, if I was minting these tokens and they were giving users access to secret resources, then I probably wouldn't give them out to just anybody. So it's pretty much the rule that every client which wants to operate at this protocol has to register with the authorization server, mainly so it can authenticate. I mean, the opposite point of view would be if you don't want to have registration, then you have to live with any client can get access without providing a secret. So you would probably limit the kind of resources that kind of client could access, right? It's almost meaningless at that point. So basically, you need to register. You need to register with the authorization server. I wonder if has anybody seen one of these pages, like on one of the commercial sites? I could just show you one quickly. If I log into GitHub, for instance. Oh, I'm not on the internet. Okay, I'm not even going to bother. If I logged into GitHub, I could show you my client registrations, right? In my account on GitHub has some clients registered with it that I can use for testing or for collecting your user profiles if that's what I want to do. So you register with the authorization server. One thing that you're not supposed to do as a client application, and that's actually the whole point of OAuth, and the whole point of having a complicated protocol, is you're not supposed to actually collect users' credentials. You don't ask them for their password, and any user who gives a password to a client application, is kind of acting understandably but irrationally. The client shouldn't do that, and any auth server which finds a client who is collecting user credentials should shut them down. That's another reason for registering. And another opportunity for data modeling, right? How would you shut down a client and prevent them from obtaining tokens? So third responsibility of a client is to obtain tokens from the authorization server, either on its own behalf or on behalf of a user. If it's on its own behalf, then there's one way to do it. It's specified in the spec, and that was that little sequence diagram I showed you at the beginning. It's called a client credentials grant. So I'm granting a token as the authorization server, and I'm granting it to a client in return for his credentials. It's client credentials exchanged for token. If the token's on behalf of a user, there are actually 3 ways in the core spec specified to do that. One of them was that complicated approvals dance that I showed you, and that's called authorization code grant. And so those are the 2 core use cases. I can talk about the others if you're interested, but most of the interesting detail will be covered by talking about those 2, client credentials and authorization code, I mean. And then once you've got a token, you use it to access the resource server in ways that I've described. Okay, so if you're the resource server in this game, what are you supposed to do? Well, you're supposed to look at all the requests that come in and, don't open up to anybody who you don't recognize. So that's a typical security decision, right? You have to recognize such requests, extract tokens from them, decode the token so that token contains information. There are a number of different ways you might get the information out of there. You might ask the authorization server to give it to you, for instance, on kind of a remote procedure call. Or you might have access to some common storage with the authorization server, so you can both access the same information, and whoever designed the system has given you access to do that. Okay, so once you've decoded that information, then there's another interesting piece, which is you've got to make an access control decision. So in Spring Security terms, you've got to make an access decision. And so you can make that access decision based on, well, anything you want, really. But you would be well advised to take into account at least the following information. I'll come back to scope. Audience we've covered already. That's basically an identifier for myself. So if I'm accepting a token and I'm giving up resources, then I have to be sure that the token was meant for me. Because if it wasn't, then I'm giving somebody secret stuff that they're not supposed to have. There might be user account information, like I said. User ID, roles associated with the user might be in there. And there might be client information about the client who sent me the token, probably at least an identifier, right? So I can check that I know him. And okay, that brings us back to scope. So scope is basically, it's specified in the spec that basically tokens represent a scope of access. And so what does that mean? Well, that's kind of like a role, isn't it? It's the level of access that you get. So if you click on one of those approval pages on Facebook or Google, it's saying things like, do you approve this client application X to write on your timeline, in the case of Facebook. And so write on your timeline is, in English words, for some string that is shared between the resource server and the authorization server, basically. And that's the scope. It's a level of access. So this is where it's interesting, right? So the spec says that tokens contain scope, but it doesn't say what that scope means. It just says that it's a string, and it says that you format them as comma-separated lists and things like that. It doesn't really tell you what they are or how to use them. It's up to you, which is interesting, right? So it's a way to do data modeling here. So for instance, I can already say, well, maybe a scope could represent the roles that the user has in my user database. Like, you could already equate that, and that would be a data modeling decision, and then we've done something interesting, right? We've kind of, why is it interesting? Because we've tied a decision that the resource server has made with the user data store on the authorization server, right? So they've communicated just through a string that they share some common associations, some common meanings for, but nobody else necessarily will be able to interpret. It wouldn't matter if they did, but it's up to the resource server and the authorization server to agree on this contract, basically, is all I'm trying to say. If it can't make that decision, then probably it should send the client a signal that it can respond to, like a 403, for instance, forbidden, if you can't access this resource. It's common, and it also is mentioned in the spec as a sort of should have. It's common if you send a 403 to send some kind of reason, right? You send a www-authenticate header, and you say, you can't do this, but if you wanted to, then you could send me a token with the following scopes, and that's what the spec recommends, although it doesn't mandate. And I can show you that hopefully in action. Okay, then the final piece of the puzzle then is that what's the authorization server doing in this? Well, he's minting tokens, so he's got to do some computation, actually. He doesn't just grant tokens to anybody who asks, right? And under all circumstances, he computes the token content and decides when he's computing that on he's got various decision processes he can go through before he actually finally grants it, and then sends it to the client usually in an HTTP response body. So there's some business logic there, or a security logic, if you like. Also, I guess not mandatory, of course, but the authorization server has to obtain approval. That's mandatory. How is he going to do that? Well, he probably has to provide some sort of user interface, right, in order to prompt the user to say, yes, I approve this, or no, I don't. So it has to probably provide a user interface with checkboxes and buttons and accept and deny and that kind of thing. He also, interestingly, and you might forget a bit if you weren't careful, he has to authenticate everybody. He has to authenticate the user if there's a user involved. So the user comes in, having been redirected by a client probably, to the authorization endpoint. A standard procedure then would be to make sure that the user was authenticated. Yes?
You hear a lot about two-legged versus three-legged.
Right.
Is that equal to whether there's a user involved or
Roughly speaking, but those terms were part of the OAuth1 spec, and they aren't used in OAuth2. However, you can sort of equate, you can sort of equate the legs with the participants, the client, the resource server, and the auth server. That's 3 legs, right? And client getting a client credentials grant directly from the auth server, that's 2. So people use those terms loosely with the OAuth2, but they have very precise meanings in OAuth1, which I don't want to go into in particular. It's better to talk about grant types, because that's the language of the spec for OAuth2. So then it's clear that you're talking about either authorization code or client credentials, or one of the others. Okay, so authentication. You get redirected to the authorization endpoint, which is, I mean, there's nothing in the spec that says it must be /authorize, but it makes sense if it is, because then everybody knows what it means, and most of the common ones that I know of kind of look like that. So the user comes in via the browser to that endpoint. The authorization server has to, there should and must, in fact, authenticate the user, which might mean another step, another redirect, right? Go to the login page, fill in your details, or whatever you have to do to authenticate the user. Again, not mandated by the spec. Only the mechanism is not mandated, only that the user should be authenticated. I mean, it makes perfect sense. You wouldn't do this any other way, but the spec also doesn't say how to do it. Good, because we can do it any way we want. And then the second leg, the back channel, which is client obtains token from authorization server, that also has to be authenticated, which is why you have client registration and secrets. Okay, so 1 and 4 are covered pretty thoroughly by the spec, although in the case of 4, it only kind of makes some suggestions about how the authentication should actually be done. It says that basic authentication is adequate, so that's what most people do. And 2 and 3 are not, and that's for a good reason, because there are plenty of choices that you can make, and they all make sense. So here's where we start to form some opinions, okay? And I'm going to show, a few different approaches just so you can get a flavor for it. And all of the flavors that I show you will be, I guess, implemented with OAuth2, Spring Security OAuth2 in the background. So this is a project that I'm involved in. I guess you could say I'm the project lead, but mainly because nobody else does it. So it's kind of my pet project, and we used it heavily in Cloud Foundry. It was the 1.0 release of this was kind of, it was carefully managed to the point where it was good enough for the Cloud Foundry in production, and we didn't take it any further because I had a day job at that point. Now I'm starting to get more interested again. I'm trying to take it to 1.1, and actually one of the reasons for that is the Cloud Foundry kind of diverged from the OAuth library we had at version 1.0, so we're having business requirements thrown at us, and we've got to respond in some way. So the goal of Spring Security OAuth2 is mainly, I guess, on the server side of this protocol that we've been talking about, the resource server and the authorization server. Those are the core competencies, I would say, of Spring Security OAuth. If you want to use Spring OAuth for a client, you can as well. We have client support, and I actually quite like the way that it works. There are other options on the client side, and people use OAuth2 on the client side in a variety of different languages, so they're not even all Java, never mind not even all Spring. There are several options in Java. There are 2 options at least in Spring, and depending on the platform that you're trying to approach, there are maybe even more than that. So I'm thinking about Spring Social, by the way, so I'm sure Craig's off talking independently about client-side OAuth2 somewhere else. But if you get a chance to see Craig's talks, go to those, because then you get a flavor for how the client side works as well. I'm mainly concentrating on the server side, but like I said, we have client-side support just to be complete. I use it because if I'm doing server-side work with OAuth2, I might as well use it on the client as well, but it doesn't mean that I have to. It just saves me having another dependency. So we've had a few releases of 1.0, I said, mainly to support the fundamentals of what we needed in Cloud Foundry. 1.1 I'm working on. I'm going to show you some work in progress, hopefully, if we get that far. Because 1.1 has diverged from 1.0 in interesting ways that have data modeling implications. Okay, so in terms of Spring OAuth, the responsibilities that we've been looking at in the protocol, the authorization server is, roughly speaking, implemented as an MVC endpoint. Authorization endpoint, it's a Spring MVC, at controller, at request mapping, etc. It's a little bit unusual in the sense that it's not because we need to make it flexible, we need to be able to make it configurable declaratively so that you can change the URL, for instance, in the endpoint, and that's not something that Spring MVC commonly does, so we try to kind of make a special abstraction for it. But fundamentally, it's a Spring MVC endpoint. And so is the token endpoint. So the /authorize and /token, the Spring MVC endpoints, I think that's good, right? Because then anybody who works with Spring and Spring MVC knows basically how to analyze them. And more importantly, knows how to protect them, right? You use Spring Security, vanilla Spring Security, nothing to do with OAuth necessarily, to protect those endpoints, right? You just put filters in front of them, and then you've got all of the security requirements you need for those endpoints without OAuth, the project OAuth, having to do anything about it. It's just a Spring Security feature. The resource server is, I think, predictably a Spring Security filter. So you have just your own normal MVC or other, you could use JAX-RS or whatever you wanted on the server side of the resource server. You put a Spring Security filter in front of it, and you give that filter enough information to do that access decision that I was talking about that the resource server has to make. So it has to take the request, extract the token, decode it, make an access decision. And all that sort of stuff is kind of bread and butter for Spring Security, right? So all we really need to do is add a filter and a few kind of extension points, injection points, in fact, for extensions that you would need to add to, for instance, specify the form of the access decision. Is it based on scope? Is it based on roles? Is it based on, time of the month? Whatever. So the access decision is just a Spring Security feature, and the filter is there as part of the Spring Security chain. On the client side, I think it's useful stuff. So on the client side, you've got OAuth2 REST template. So it's a REST operations interface. It's built on top of it, extends the Spring REST template. And the basic idea with that is that as a client, all you want to do is access a RESTful resource. You don't actually care that it's protected with OAuth2. You just want to use it as its REST operations interface. And so the whole design was basically orientated around that point of view, that model of the universe. Spring Social took a slightly different view, right? So that's why we've got two different implementations of clients, because if you like just using REST operations, this might feel nice, might feel best, I don't know, might not. If you like sort of, something more domain specific, then Spring Social's what's going to give it to you, probably. Okay, so there's a picture. If Spring was acting as a resource server, I gave it to you in your words just now. Here's a picture. The client is trying to access a resource. So if I'm implementing this system as a resource server, I put a filter in front of it just using standard Spring Security features. Spring Security has this filter chain, right? And I can inject filters, custom filters into that chain, so that's what I do. It's a standard feature of Spring Security. And what that filter needs to do, basically, fundamentally, it needs to be able to decode the tokens. So that is encapsulated in this interface, resource server token services. I can give it a token, and it'll give me authentication information, basically. It'll give me an OAuth2 authentication containing information about the client and the user. And it's Spring Security, so you would expect that to be, a movable feast, basically. It's based on authentication, the authentication interface in Spring Security. And you can extract whatever information is in there, and because it's a contract between you and the auth server, it might be different depending on the implementation. If you're acting as an authorization server using Spring, then it looks like this. Like I said, it's two different MVC endpoints, token endpoint, authorization endpoint. Both of them have standard Spring Security filters in front of them for doing authentication, one of the client, one of the user. And those guys are served by authorization server token services. So the token services in this case is the, I guess where the token granting and minting decisions are all made. So it's an interface. It's only a few methods, 3 maybe. I can't remember exactly. Slightly different interface than resource server token services, but because it's to do with the same tokens, they might share a certain amount of logic because basically they embody the contract between the 2 servers.
You refer to the basic auth from the client. That would be with like a key and secret that supplies them?
Yeah, so the question was, is basic auth from the client a key and a secret? Yes, that's what it is. So it's just HTTP basic authorization : basic space gobbledygook, and the gobbledygook is base 64 encoded username password, standard HTTP basic authentication. I mean, that's not mandatory, right? That's just common. That's what the spec says would be sensible. It's, you know, the least you could do, basically. Protect this channel with a secure socket layer and demand some sort of authentication. Basic is fine, but if you could think of something else, I would accept it. I don't really.
But presumably you would have some type of registration process or something.
Yeah, I mean, you have to be able to authenticate the client. That's the fundamental business objective. You have to be able to authenticate the client. So it has to be something, you know the standard mantra, right? Something you have, something you know. So with a machine client, it's pretty much going to be a secret. I mean, it might be some sort of token as well, but it's pretty much going to be a secret. On the client side, you've got this REST template at the bottom. So if I'm implementing some business service and I'm in that business service, I'm going to use a REST template to access a resource server somewhere. I'm just going to inject that thing into the service and use it as if it was just a normal REST template. And for all that to work, I have to have a special filter in front of the service. So this is aimed, well, I guess this isn't exclusively going to work this way, but if you're doing auth code or implicit grants, if you're doing user tokens, then it's very typical for it to be a web application, so therefore you have a filter available. So that's the way it's implemented. If it was a client credentials grant, actually you obviously don't need the filter because I don't need to do anything special with that. I just need to contact the token server. This thing is responsible for orchestrating that, you know, protocol redirect, bounce backwards and forwards between the authorization server. And the last piece that I didn't mention yet is OAuth2 protected resource, which is, it wasn't my name actually because I inherited this project from somebody, but really that's a representation of the client. As much information as the client application needs to know about its own registration, right? So it'll have the secret in it, for instance. Okay, so let's take a look at, with all that information buzzing around our heads, and it's quite a lot to take in if you haven't seen any of it before. Let's identify again some of those data modeling opportunities. And then maybe I'll show you them in action at that point. So I'm about halfway through. That makes sense, doesn't it? Okay, so these are just as a kind of a shopping list. You could maybe add more, but these are the things that occurred to me immediately because these are the things that I have myself, I guess, modeled in various different ways. So the token format itself, you're sending strings between auth server, client, resource server. It's called an access token. You could choose to, make that string anything you like, basically. It's just a string as far as the participants are concerned. So what format would that string take? Well, we can have a look at different choices there. What would be the business or the security context, security information encoded in that string? So what, we've talked about that already a little bit, audience, client ID, what else are you going to put in there? The client registrations themselves obviously have to have some data store behind them. It might be in memory in simple cases, but they somehow have to represent all the details that they need to make those access decisions. A big area that's up for grabs and something that you can add a lot of value with is computing permissions, right? So the client wants to obtain an access token to get hold of a resource over here. You know, I don't want that client, as a user, I don't want that client writing on my timeline. So that's a sort of, you know, business expression of a constraint. How can that constraint be enforced, right? How can you compute what this client is allowed to do on behalf of this user in this resource, right? There's lots of participants there in that quick sentence description. So lots of opportunities for modeling the interactions and computing the outcome. User approvals, so the user has to approve the grant of the token if there is a user involved. You could model that in a number of different ways, right? I'll show you 2, 3 maybe, in terms of data modeling. And then you've got, I guess, even first and foremost, you've got to authenticate users. So you have to represent users and secrets, and maybe not secrets, maybe, I don't know, something you have, right? So maybe it's a hard token that's encoded, but there's data modeling to be done there as well. Sorry, was there a question somewhere? No, somebody just yawning. Okay, so the first thing we can look at is the token format. So as far as the spec's concerned, and actually as far as the client's concerned, this token is completely opaque. So I'm not supposed, as a client, I'm not supposed to need to understand what's in there. So, you know, they might as well just be completely opaque. They could be a key to a data store somewhere that contains more rich information. That would be a simple modeling choice. But they do carry important information to the resource servers. The resource servers have to take those tokens and assign context to them, information to them. So they have to be able to do that in some way. One way to do that would be to encode all that information actually in the string itself. And that's what we've done in the Cloud Foundry implementation that we did, you know, from, actually not from the beginning, but from probably about a year ago, year and a bit ago maybe. We started using these JWT in tokens, and there is some signing going on here, right? So if you do this, right, if your choice is not to be completely opaque, if your choice is to encode security information in the token, then you really have to take some extra steps to make sure that that token can't be used by the wrong people in the wrong way. And one way you can do that is you can prevent it from being manipulated, right? So if I get your token and you've given me access to read your timeline but not write it, you don't want me to be able to just rewrite the contents of the token and then send it to the Facebook API to write on my timeline. So I need to be able to preserve the contents of the token, therefore I need to be able to sign it, therefore the resource server needs to be able to verify that the signature is correct. So there's a contract and the secrets shared between the secrets or keys, symmetric or asymmetric, shared between the resource server and the authorization server. If you go down this route, right, that's the implication. If you go down the route of encoding information in the token, then you will find that you have to sign it. So I might as well just show you that because I can do it really quickly as it happens. I did last night, I did CF push blah, 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 an application, right? So CF, if I can remember, I think I'm a bit rusty on it, looks in the local file system for a file called tokens.yaml. And in that tokens.yaml, you will see secret information, and I'm just wondering whether I'm going to give you, maybe I won't, maybe I will, it doesn't matter really, I can change it again afterwards. That's the good thing about access tokens, right? They're ephemeral. I can just get another one tomorrow, and then it won't be the one that you saw on the screen just now, if you're watching this on video. So there you have, for api.run.pivotal.io, which is where I was deploying last night, you have a bearer token with this value, quite a long string, but not infinitely long. So if I just copy that into a variable, and then I can hide it again. So I can actually decode that myself, but it's a bit more difficult to verify the signature. That's part of the trick, I guess, to this. So as a client, I could just echo it and base64 decode it, maybe. I don't know. Should we try it? No, that doesn't work. Okay, I need to, how do I do this? I've forgotten my Unix command line. I need to cut it with a, how do I do record separator? -c dot, thank you. And then -f for the field number. I don't know, something like that. No, cut, man cut. Sorry, I should have practiced this. C is for columns, characters it says there. D for delimiter, right, that's what I want. D for delimiter, F for field. Thank you. So I think it might be the second field, I don't know, we'll see. Yeah, there you go. So the second field has all that information in it, base64 encoded. So the token is a JOT token, and there's a spec for that, right? And we've implemented it in Spring Security OAuth2 actually already. There's a separate jar file called Spring Security JOT 1.0.jar, and it basically has Java APIs for doing that, and also checking signatures and signing and checking signatures. And so once I've decoded that stuff, well, actually, once I've encrypted it, what I've got encrypted, once I've encoded it, what I've got is a period-separated string. The second field is the business content. The third field, I think if I remember correctly, is the signature. So if I'm being a good citizen, what I should do is decode the second field and then use the third field to check the contents and make sure that they're the same as was in the token when it was granted. Okay. Now let's just have a look at this in a bit more detail. What have we got there? I'll just parse it out for us. JS. Print it out a bit nicer. Okay, so there's pretty printed. So it's a JOT, so it has an identity, an identifier. It has some scope, so this is OAuth2 stuff. This says, with this token, I'm allowed to change my password. I'm also allowed to use this token to authenticate. So that OpenID says I can get my user details using this token. And I can push stuff to the cloud controller using the write scope, and I can read stuff from the cloud controller using the read token. So I can read and write the cloud controller content. And that actually is an interesting modeling choice that we've already made. Implicitly there, we've got a naming convention or a format in the scopes, right? Nobody said they had to look like that. They sort of have English words in them that make sense, and the cloud controller ones have also, and the password one, in fact, as well, have got a period-separated naming convention, and that's what we use internally in this system to identify resource IDs, audiences, basically. So this token implicitly has an audience of cloud controller and password and OpenID, which you would find possibly at the bottom. Actually, the audience for this token has an additional entry, but those three that I mentioned are there, definitely there, and those are extracted by convention from the scope names. And that's a modeling choice that we made, and we found it really powerful, actually. We found it very useful to be able to carry that information around and make it all internally consistent, right? So that the token contains information about the position, the permission it's allowed to use, and also which resources it's allowed to access. So the password and OpenID resources, for instance, are on the UAA component of Cloud Foundry, and the cloud controller is its own resource server. So I've got two different servers I can access with this same token. That's a question.
Doesn't this essentially like version your tokens? So if you wanted to change this format, you would have updated tokens that didn't contain information?
Okay, so the question is, does this version my tokens, and if I wanted to change the format, would that mean that all my tokens were invalid? Yes. Yeah, I mean, you know, that's a standard problem, right, with API expansion. If you want to add fields, that's usually okay. If you want to take them away, that's probably not so okay. I mean, the saving grace with this is always the fact that these things are ephemeral, as I said. So this only actually lasts for about an hour, I think it is now. So, you know, by the end of this talk, it'll be invalid anyway. So I could change the format, and who would care, right? Because the client doesn't really need to know what's in there. And when I changed it, the challenge would be for the resource server to be able to always know what was in the token, and that's just the same as any other API change, data model change, right? If you add fields, it's safe. If you take them away, then you have to make sure that your participants are aware of the change and react accordingly, right? So there's nothing really new there. It's challenging, it's difficult, but there's nothing unique to this problem there. It's just API change, really. But good point. Yeah, yep. Okay, so you're asking for an opinion. What's the benefit of encoding information in the token as opposed to using it as an opaque key? Well, I can tell you what the official story is from the guys who asked us to do it this way. So the people who wrote the cloud controller said, no, we don't want to contact the UAA every time we want to decode a token. And that's actually a valid point of view. I accept that opinion, so that's what drove us to do this. It was the clients, well, not clients, I guess the resource server implementations wanted this. So that was the contract that we set up with the authorization server. They wanted it for performance reasons. They didn't want everybody contacting the UAA every time they wanted to decode a token. Seems reasonable. I mean, there's a downside, right, which is that if this thing has a short lifetime, an hour, but there's nothing I can do for an hour to revoke this token, right? Whereas if it was a lookup, an opaque lookup in a data store, I can delete that data and then they don't have access anymore. So there's a really important decision to make there. Do you want to have high scalability, you never have to contact home to decode the token, or do you want immediate revocation, but potentially a bottleneck in the data store and a credentials problem with the data store? So there are some interesting choices to make there. This is the one we made in Cloud Foundry. What I'm busy doing with Spring OAuth as we speak, or when I get back to it after this presentation at least anyway, is widening the choices. So we found, the default behavior in Spring Security OAuth is opaque tokens and a shared store between the servers. Seems to work for a lot of people, but there are some use cases where it's constraining, and so we did it this way in Cloud Foundry, and we found that other people want to do it this way, so we're making that feature available in Spring OAuth in 1.1, basically. Sorry, you had another question?
Well, don't you still need a shared store to get the secret to decode?
You need, well,
because you don't want them modifying.
you don't know. So you have to verify the signature on this. Two ways to do that, right? Standard cryptography, you either share a secret, which might be a shared store, or frankly, it could just be config files, which is what it was in Cloud Foundry when we operated that way. So for a few months, maybe 6 months, can't remember, it took longer than it should have done. We had shared secrets in config files in the platform that you use to verify the signatures. Now it's done with asymmetric keys, so the UAA in Cloud Foundry actually has a RESTful endpoint that you can ask it for its public key from. So then you can use the public key to verify the signature without knowing any secrets. There's two ways of doing that. Okay, so I've opened your eyes, hopefully, to a whole world of possibility. So here we go, a summary slide of what we've just been talking about. So you either have shared storage and opaque tokens, or you could have, and this is another option that we provide in the UAA in Cloud Foundry, and some clients use it, some resource servers use it, I should say, is you could still have an opaque token, but you have to ask a central server, not a shared store, but a central server, you have to ask it to decode the token. Nothing to do with the spec, right? The spec just says basically the resource server has to be able to decode the token. It makes sense to me that you could do it through an endpoint, so we provided that. incidentally, I think that's an OAuth2 protected endpoint, but again, nobody's going to tell you how to authenticate that. Or third choice, you can have resources decoded locally and signed, and the signature is verified. Possibly also encrypted. People do sometimes encrypt the data in there as well. If you did that, that's just an extra step, an extra cryptography step, and extra secrets to protect, probably. So 2 and 3 obviously require some key management between the various participants there. Option 1, you still need credentials for something, right? Because they need to access to the data store. So, I mean, you look at it all ways around, then you've solved the same problem 3 different ways. It's really just a matter of taste. Now I'm sounding like somebody without an opinion, right? Certainly. Okay, so token contents we've covered. Token audience, a bit more detail. You need to check if you're a resource server that the token was aimed at you. In Spring OAuth, every resource has a resource ID. That's the domain language that we use. In the JOT token, it's called an audience. In the spec, the OAuth2 spec, it doesn't mention it at all, so I feel like we're free to make that choice. That's just a couple of conventions that you'll see. One of them we chose in Spring Security before anybody really started doing anything more complicated or different. JOT came along and we started using it in UAA, so probably I would have used audience from day 1 if I'd been writing Spring Security OAuth from scratch now, but anyway, it's called resource ID. Okay, client registration data. ID, secret, definitely going to need that because they have to authenticate to the token endpoint. Third thing that they need, and they need to have registered, is a redirect URI so that you protect. In that way, you protect against various spoofing attacks, basically. So I can't pretend to be this client and sit at a different URL than the one that was registered, right? So if you don't register a URL, you're free not to register a URL, especially with Spring Security OAuth. You're not free not to register a URL with Cloud Foundry, Facebook, Google, anybody who actually provides this service because it's not secure, right? So you need to provide a redirect URI, which is normally, it's not totally fixed in, it's not an exact comparison that's going to deny or refuse access. So the recipe would be this, right? The authorization server, it's his responsibility in this case. The authorization server gets a request from a client that says, I want you to give this, approve this, get the approval from this user, and then send him back to me. And when you say send him back to me, what you mean is redirect URI equals something that matches this thing that I've registered. And so matches is a loose term. The spec doesn't say how you do it. That's fine, because it should be done in different ways. There was a famous snafu with Facebook where they got it wrong, basically. They were too lax with their matching, so you do have to be a little bit careful with this. We screwed it up once as well. Luke fixed it for us within a few weeks of noticing, and nobody else seemed to notice. So if you're not careful with this, you could be exposing security holes, right? Exact matches are fine, but they're really inconvenient for clients because the client can then only accept redirects on a single endpoint, whereas actually they probably want to accept it on a range of different endpoints that just basically have the same host name and the same protocol. The redirect URI should be SSL protected. It should be HTTPS as well. That should be enforced by an authorization server, but obviously the spec isn't going to tell you to do that. You have to work that out for yourself. And of course, if I'm an authorization server, I need to know if a client's asking for a token, I need to know if he's allowed to get it. I also need to know if he's allowed to get it in this particular way, right? So some clients just aren't allowed to have tokens on behalf of users. I don't allow it. I don't want that to happen. So we can deny it based on the grant type. Okay, and then the scopes also would be part of the registration, typically speaking. So I'm going to, as an auth server, I'm going to grant this client a token, and the token's going to have scopes in it, and the scopes will then be used by the resource server to compute some permissions, right? So that's important information. I'd better do some checking on that. I'd better not just give it anything it asks for. And so in particular, what I'm going to do is I'm going to register scopes with the client and say, these are the scopes that are available to that client. And that's Again, nothing that's specified in the spec, but it's just logical you have to do that, otherwise you wouldn't protect yourself in any way, in a meaningful way. So Spring Security OAuth has this model. A client registration has scopes, which are the scopes that it is allowed to have when it's granted a token. And the client also in Spring Security OAuth, interestingly, has authorities in the Spring Security sense. So that was a choice, a data modeling choice that wasn't made by me. It was there in the code base when I joined, and I don't know, it seemed to make sense because it kind of appeals to the Spring Security audience, right? They know what an authority is, and now it's up to us to, to actually give it some meaning. What we've done in Cloud Foundry is we distinguish between the scopes that a client is allowed to get on behalf of a user, we call that scopes, and those that it's allowed to obtain on its own behalf. So we make this equation between authorities and scopes. They're the same strings, they're the same set, basically. They're drawn from the same set of strings, but one of them is used in the client credentials grant, and the other one's used in all the other grants, basically. So that's an interesting modeling choice that we made. It's 20 minutes left. I've got a nasty feeling I'm going to run out of time for demos completely. So I'm going to make some choices. Yeah, okay, so client registration data, you should at least have IDs, secrets, redirect URIs. Other stuff, it might actually well be useful, especially when it comes to computing the token contents, because the token contents embodies in some sense what the user's allowed to do as well as what the client's allowed to do. So there's multiple participants in that, or multiple relations in that decision. In terms of the way that people interpret scopes, in the internet, in the interweb, Google has this URI format for their scopes. Facebook has kind of meaningful short strings. The UAA has period-separated naming conventions. So, pay your money, take your choice. I won't actually have an opinion on this because they all work. They all work basically, though, in the same way. They work by expressing permissions, and you need to do some work on the authorization server to, model what permissions are available and assign them to users and clients so that you don't grant tokens with the wrong scope. So, a simple example of a scope computation would be the client requests a specific scope in its authorization request. The authorization server looks at the client's authorities and sees that he's allowed to get read access but not write, so he narrows the scope of the token and says, okay, you can have it, but you're only going to get the read scope, not the write scope. And that might be a bit of a nasty surprise for the client, because he won't, if it's an opaque token, right, he might not know that he's got a lower scope than he asked for until he tries to use it. But, tough luck. That's what the RESTful resource model is for. The client tries to access a resource, he doesn't have access, he's going to get a 403 with a www authenticate header saying, no, you need write access for that, and you haven't got it. So that's the approach that we've taken, at least in Spring Security, is to rely on the HTTP protocol to decide ultimately whether you get access or not. In Cloud Foundry, we've got a slightly more complicated computation. It's to do with the client having scopes and the user having groups in the user database. So there's a user database with every user is allowed to belong to multiple groups. It's a static directory model, basically, except we've done it in a relational database. So we compute scopes in a sensible way, I think. Because we have this, the thing that allows us to do that, to make it sensible, I should explain, is the group names are the same as the scope names. That's basically the rule. So if a client asks for a token with a given scope, we look at the user's groups, and we only grant the scopes that the user is a member of the group with the same name. That's relatively simple to explain, and hopefully it makes sense, but I'm putting it on the slides here because I'm saying we made a choice. We have an opinion on this, we found it valuable. And incidentally, if you think that that is a sensible choice, then you're more than free to download the code for the UAA, run it as a server, and use it, right? It's fully formed out of the box. It will allow you to provision user accounts. It will issue tokens. It will decode them for you. It's fully featured, and it has made some choices like this one. At which point I should, I think what I'll do is I'll run one quick demo. Yeah, so actually probably what I'll do is I'll check out a feature branch from Spring Security that I'm working on to do with approvals, and I'll make sure that that's up to date. Then, if you want to get to grips with this stuff, then this is a really good place to start, right? There are sample apps here in the Spring Security code base. Sparkler 2, Toner 2 are the OAuth2 examples. If you run them in the same Tomcat container together, they basically just work. They have some interesting features which I'm just about to show you. Yeah, Rob did some Java config for OAuth2. It's in a separate GitHub repo. You can find it easily, Spring Security Java config OAuth, something like that. My plan is to take that and fold it into this for 1.1, but I haven't got around to doing that yet. Rob was extremely thorough about all that stuff when he did it. So I'll just launch that server just so you can see how to do it and make sure that I'm not hiding anything. I can do this in Firefox, I'm sure. So OT80 has Toner 2 is the client. And from that client, I can access Facebook resources and Sparkler resources on that Sparkler server, which is both an authorization server and a resource server in the same way that Facebook is actually. So that's not uncommon. It's not what we've got in, it's not the entire picture, at least anyway, in Cloud Foundry, because the UAA is an authorization server and the cloud controller is a resource server, so they tend to be different URLs. But here, I'm going to look at my resources on the Sparkler app are pictures. Right, I can look at them. As long as I can authenticate first with Toner, right, I've just authenticated with the client. Now I'm authenticating with the authorization server. What happened there, maybe I could do that again so you can actually see it. What happened there was the redirect. So when I click on Sparkler Pics, what actually happens is the browser tried to go to Sparkler Photos, right? That's a protected resource, OAuth2 protected resource. And he said, oh, you don't have a token yet. You better go and get one for me. You can get it here. You can get it from /OAuth/authorize. That's the authorization endpoint on the Sparkler 2. And he said, oh, wait a minute. I need to authenticate you. You can't have that. I can't have anything yet. You'll have to go back to the login page. Two redirects, right? One from the client to the resource server, one from the resource server. Sorry, one from the resource server to the auth server, and then one from the auth server to itself to get authentication. So I can authenticate as Marissa. If I do that, I will be presented with this low-grade user experience, but it's just a demo, right? I can approve or deny the read or the write scope, and I better approve something or I won't be able to do anything, but I know I'm only trying to look at my pictures, so I don't need to give it write access, right? And then I can submit and see my pictures. So the reason I went onto a branch there to do that is because I've recently implemented that page, right, with the approvals on it, because it wasn't there before. In 1.0, you just had a token store and an opaque token. The opaque token wasn't really enough to store granular approvals in, so I couldn't build the UI that goes with that easily, at least anyway. And what I've now got in Spring Security is an approvals abstraction, which I'm going to get to now. Okay, so this would be kind of the vanilla 1.0 picture in Spring Security. A token has client identifier, user identifier, and scopes. Optionally, the user identifier, I guess. What if I make a sort of mental adjustment and just say, well, that token had to be approved, so that is the approval model, right? The user has approved those scopes for this client, and that data is all encoded in the token, so the token is a representation of the approvals. All right, so that's basically the 1.0 model of OAuth2, Spring Security OAuth2, and the UAA as it was at the time when we first started it. The UAA, though, developed this additional structure, and we found that that was useful because then we could present that kind of screen to users and say, here are the different things that the client wants to do. You can approve some of them or all of them, but you don't have to approve all of them if you don't want to. And the only way we could do that was to explicitly model a token as a set of approvals, basically. And then the approvals themselves have that information. Each approval has a scope, a user, and a client. And so there's a very sort of basic ER diagram that shows you how that works. That's the new abstraction that I'm putting in Spring Security OAuth 2, so you have the choice. And in fact, you have two choices even there, because the demo I just showed you with Sparkler 2, it doesn't have a separate approval store. It still has, and I think this is a perfectly valid choice, right? Going back to the question that I had from the back. It's a perfectly valid choice just to have opaque tokens, which are keys into a backend store. And I can always get the information from that backend store that I need about which approvals have been granted. So all I really need to manage that data is the, that screen that the user gets. I need to collect the data that he sends me. And if I collect that data and encode it in tokens, I can reconstruct everything post hoc. And that's the way that that demo is working, but it's not the only choice, because the other choice is to have an approval store instead of a token store. I think I'm still in two minds about whether I would ever need to have both, put it that way. I may come down on the side of having both at some point, but at the minute I'm thinking you either want a token store or you want an approval store. You probably don't want to bother yourself with both. So if you have a token store, what I've done is I've given you the option of still making a granular request to the users for their approval and then using that to encode the token. Final section, I think, on authentication, because it's an important modeling choice that you have implicitly made somewhere. I wouldn't have much to say about this, except that authentication, as I always say in these talks, is orthogonal to everything else. So you can make that choice to authenticate in any way you want, and you should feel free to do so. I think that's really the punchline as an auth server. That's just a diagram that shows you the names of the components in Cloud Controller in the Cloud Foundry. Sorry, the UAA is the one that I was responsible for. It's implemented with Spring Security, Java. The advantage of having done it that way is that it's actually incredibly easy now. Well, to use it as a standalone OAuth2 service if you want to do that. If you want a token minting service, then that's a really good one. It's also really good for extending into other realms that Spring Security handles really well, like LDAP data stores for user credentials, for instance. If you're in the enterprise and you want to have your own data store and not use the one that comes with the UAA, actually we make that quite easy, because Spring Security it's a doddle, right? It's a few lines of code and you've changed your authentication store. Some complications to do with that, but we've started to cover them off, and we are actually deploying it now in Cloud Foundry is being deployed in enterprises as we speak, and they're using their own data stores. So we've proved that it can be done. The other interesting fact there is the other interesting feature that Spring Security has is, for the enterprise at least, is SAML. So what's the SAML story? Isn't it supposed to be all OAuth2, hippie, scripty, curl it, and it's good? Yes, but of course existing enterprises have their own single sign-on systems. They're often not as friendly as we'd like them to be, and if they're implemented as SAML authorities, then there's not much we can do about it except suck it up and use that as an authentication mechanism. That's what we've done. So Spring Security SAML is pretty good. It's really easy to configure as a service provider. So we just make another config change. Basically, you've switched it from a UAA's native data store to an LDAP data store to a SAML token-based authentication. And it's quite easy to do just because we've used Spring Security. I don't know how we would have done that if it wasn't Spring Security. Okay, then you've got consumer side. Using, this is something that they all do, broadly speaking, right? Actually, interesting fact here. So GitHub, it has an OAuth2 protected API. And it follows this pattern, right? So GitHub, did I provide that endpoint there? Yeah, GitHub has api.github.com/user. If I hit that endpoint with an access token, it tells me about the user who is represented by that access token, right? It tells me all the public information about that user if it's if it's not me, and if it's me, it tells me everything I've told it about it. So that's kind of useful. And that's useful because you can use that to do authentication, right? So and that's actually what we've done with the Spring IO website. You saw it yesterday. You don't need to authenticate to get access to that, but we do because we write blogs, we manage our team profile, we do stuff where we have to identify ourselves. And rather than have our own data store for that, we thought, well, everybody's got a GitHub account. It's really super easy to just hit that endpoint, github.com/user, and we'll find out about the user who's simultaneously logged into GitHub. We know who you are now. If you're on the Spring team, we can identify you because there's a GitHub Spring team. We'll give you access, and we've authenticated you, and we know about you as much as you've made available from your public profile, which is enough, basically. So this is saying you can use OAuth2 for a single sign-on, basically, which is what we've done in Spring.io. Not that you'd notice, because unless you were in the Spring team, you wouldn't be able to authenticate. OK, so quick wrap-up. In terms of if you were looking for API extension points, if you want to express those modeling decisions that we've been talking about, where would you look? So in Spring OAuth, you would look at, for instance, token enhancer. That would be something that you could use to you could do two things, actually. You could add additional information to the fields that are represented by the token, if it was opaque. You could also change the format of the token from opaque to encoded, and that's actually what, there is a UAA token enhancer in the UAA, and that's what it does. It creates JWT tokens, JOT tokens. And actually now in 1.1, there's a similar thing in Spring Security OAuth. User approval handler is an authorization server strategy that you use to make the decision about whether the user has approved you or not, right? And so we found that very useful in Cloud Foundry. I'm sure Facebook and GitHub and everybody does exactly the same thing, because a large proportion of the users of Cloud Foundry, the clients, are actually part of the platform, right? So if you log into console.run.pivotal.io using your Cloud Foundry credentials, we don't need to ask your approval for that, right? You've given us your credentials, albeit to a different component, right? You've timed it into the console, and we're the UAA over here. But the console is a client, and it doesn't have to seek approval from the user, right? Because if the user's given it his credentials, then he must approve it. So there's an auto-approve feature in the UAA, which I'm actually also implementing in 1.1 now, because it seems like it's quite a common thing. Token store is a very common back-end choice, so JDBC, Mongo, whatever. I've seen various choices, in-memory even. We used in-memory in Cloud Foundry for a while. And an approval store, which is new. So probably one or the other. Not sure. I'm on the fence still about whether you need both. High level, the token services APIs that I showed you at the beginning. Each of those, though, has a couple of implementations, and usually the level below that is where you look for extension points. So, for instance, Authorization Server Token Services has two implementations now, one using Token Store and one using Approval Store. And so really it's probably the store that you want to attack, not the implementation of the token services itself. In the UAA, if you wanted to extend it, you could, for instance, change the store for user information, and that would be one way of doing it. I don't want to spend too much time on that because I'm running out of it. I've seen people using the UAA and the enterprise in both those ways, in summary. Either replacing the UAA user database, which is effectively replacing the native data store, or replacing, and then that's read-only, basically, so the UAA only really needs to know about user information and groups and be able to verify passwords or verify credentials. Doesn't matter, it doesn't have to be a password. If you want to do user provisioning, so changing the users' groups, adding user accounts, that kind of thing, then you need to do the skim strategies. So I've seen people wanting to do both, basically, depending on whether you want to have control over the provisioning or not. Very quickly, other token types. So we talked a lot about access tokens. A special kind of access token comes with a different standard called OpenID Connect, which is specifically to do with single sign-on and authentication. So a simple-minded view of that is it's just a normal OAuth2 access token, but it adds an additional ID token field to the decoded data, which gives you some information about a session, a single sign-on session. Another token type that there's a spec for, but hasn't finalized. It was dead and it was revitalized, and it's still alive, I think. So MAC tokens might be interesting for anybody who's interested in signing, and more kind of, I guess you could say, enterprise-grade security for RESTful API calls. And again, the simple-minded view is you don't just sign the token, you also sign every request with a hash of the request itself, so that you can't repeat the request. It's not just the token contents you're protecting, it's also the request itself. Not to be confused with other kinds of authentication, which I've mentioned already, SAML and LDAT, which are common. So that's actually it. That's the summary. I wish I could have done more demos. If you want to ask me later, I can do more. I think it's about time that I stopped, though. So lots of links there. The presentation itself, if you were in my previous presentation, I got it wrong. There was but this one's correct. That's my website with the presentations on it. I will also tweet about it, and you can get all the links and everything from there. So watch out for me on Twitter, @DavidSyer. Thank you.